In dealing with the electric force between two particles, there are two ways to go about that. This is the first and most straightforward way, in which we're allowed to redefine the universe such that if I have some charge Q1 and some other charge Q2, I'm allowed to define things such that I can make it a one-dimensional problem called the origin at thing 1 and some distance x is equal to r at Q2. In that case, if I want to find the electric force of thing 1 on thing 2, well, we're going to assume they're both positive charges for just a moment, which means that there'd be a repulsive force, which means that the starting expectation for thing 1 on thing 2 is radially outward. So, that would then be that constant k, very close to 9 times 10 to the 9th meters, newtons meter squared per coulomb squared, times the charge of thing 1 in coulombs, times the charge of thing 2 in coulombs, divided by the distance between them squared. And in this case, I'll just say, okay, in the x direction, radially outward. If it turns out that one of these two signs, these two things have opposite signs, positive and negative or negative and positive, then Q1, Q2 will be a negative number, whichever one happens to be true, and I'll get something in negative x direction, or back the other way, which still works. So, if I can choose my coordinate system, then this equation, the electric force of thing 1 on thing 2 is equal to k Q1 Q2 over r squared on the unit vector radially outward, is easier to deal with. All I really have to do to solve that is to find the magnitude of the electric force right there. The magnitude of the electric force of thing 1 on thing 2 is equal to just k, that constant, times Q1 times Q2 over r squared, and then solve for the magnitude, and then reason the direction.